These are the answers to our test review. The first one here says, can you identify the solutions to this equation? Again, our solutions we've been saying are just the x-intercepts. That's where the graph equals 0. And so that would be at -6 and -3. Right. So here's a table that shows inputs for this equation. And we can see that they have these values. They hit this -9 and they seem to come back. Because it's a squared graph, I know there's some symmetry. So I know that I can kind of keep that symmetry going. We'll have something like this here, all right? So x-intercepts are when y equals 0 and y equals 0 at -4 and again at 2, okay? And you could have it like this, or you could do 0, or I'm sorry, you could do it as -4, 0, and 2, 0. Again, whichever way you prefer is up to you, okay? I'll jump down here. The y-intercept then is when x equals 0, and when x was 0, y was -8. So that would be our x-intercept, okay? Now, the vertex is, again, where you make that turn. So we were going down until we got to right about here, and then it started to come back up again. So that must be the vertex, -1, -9. Right? So again, that's not too bad, just interpreting what we see off of that table there. Okay. Then we're going to draw a sketch of each of these. One solution, quadratic, is where it comes down and just hits one point and comes back up. So it just touches the x-axis and then does it. It can do it from the bottom, it can do it from the top, doesn't matter. Two solutions is when it goes through and then comes back up. And then we have two distinct solutions there. A no solution is when it doesn't touch the axis at all. All right? So those are your options there. All right, solving using zero product property. This is easy enough. I just want to know what would make this equal 0. So the number that would make that 0 would be 6, and the number that would make this 0 would be -13. Just the opposites of those, right? So when we do it by factoring, what we're going to do is find two numbers that multiply to equal this and add to equal 1 in this case. And those numbers are +5 and -4. Okay. So we factor that down. And now, again, what would make this 0? -5. What would make this 0? +4. All right, and then I get this one, and I want to solve this by factoring. So I'm going to go ahead and do this. I'd love to take that 3 out, but it doesn't go away. So I need to keep it in there. The back numbers are going to multiply to equal 4, and I need to work it out so that my outside inside gives me +1. Eventually, I would put a +4 here and a -1 there. This will give me -3, +4. That would add up to the 1. This is the factoring for that, okay? Now, as far as this one goes, that's easy. X could equal 1. That's one option. This is the one that's a little trickier, right? So I'm going to set that equal to 0 because that's what I really want. I want that to equal 0. I'm going to subtract 4 and divide by 3, and I get x equal to a -4/3. Okay, so that one's obviously a step up from this one, but similar idea. Okay. All right, then we're solving by using square roots. And so I'm going to divide by -3, divide by -3. I get x squared equal to 16. Take the square root, and we get x equal to + or -4. So 4 and -4 are our choices there. Okay. Here I'm going to subtract 11. 6x squared equals 150. I'm going to divide by 6. We're going to get x squared equal to 25. And then take the square root, and we get + or -5. So 5 and -5, okay? And then here, we'll take the square root. 2x minus 3 equals + or -7. We'll go ahead and add 3. So 2x equals 3 + or -7, and then we'll divide by 2, okay? Now, let's go ahead and work that out. 3 + 7 is 10. 10 divided by 2 is 5. 3 minus 7 is -4. -4 divided by 2 is -2. Right? So not too bad there. Square root section shouldn't be too hard. Then we get this quadratic formula and discriminant. Again, the discriminant is the part that's under the square root. So the whole thing is a quadratic formula. This is the discriminant. Okay? And we want to know what is the discriminant for this. So for this, A is 5, B is -1, C is -3. So I'm going to go -1 squared minus 4 times 5 times -3. And if I work this out, I can put this right on a calculator. I should get 61 for an answer, okay? So how many solutions does that tell us? No solution would be if the discriminant is negative. Okay, if you get a negative underneath the square root, we can't do that, so there's no solution. One solution is if the discriminant is 0. Then that would go away and we would just have one answer. If our discriminant is positive, like it is in this case, then we have 2 solutions. We'll get 2 separate things there, all right? So for number 11, we're doing the same thing here. A is 6, B is 3, C is 2. So I'm gonna go B squared minus 4 times A times C. I'm gonna get 9 minus 48. I'm gonna get a -39. That's my discriminant, okay? And again, what does that tell me? Well, if I have a negative discriminant, I have no solution on this answer, okay? So you'll have a couple questions that ask you that. Then you'll have a couple questions that want you to go ahead and work this out using the full thing. So let's go ahead and do it for this one. A is 3, B is 9, C is 5. So we're gonna go opposite of B, so -9 plus or minus the square root of B squared. 9 times 9 is 81, minus 4 times A times C, all over 2 times A. All right. Now I did that on my own. You could just write it as 9 squared first, then do the discriminant like we've been doing, separately. So if you do this, we'll get -9 plus or minus the square root. Work this out, and we should get 81 minus 60, which is 21. And then 2 times 3 on the bottom is 6. Okay, this is a good answer. This will get you most of the points. They want you, though, to work it out to the nearest hundredth. So to do that, what we're going to do is take the calculator, and we're going to type in -9 plus the square root of 21. We're going to hit enter, and then divide by 6. And one answer is -0.7, and I'll round it to 4. Okay. And then we're going to do the same thing, but this time we're going to subtract. And then divide by 6. And there's our other answer. So again, this is a good answer. Then this is what it is as decimals, right? So we'll do the same thing here, but this one is not equal to 0. So that's the trick. You got to make sure you get it equal to 0 first. So we'll have that right there, okay? So A is 1, B is 7, C is -5. So we're gonna have the opposite of B plus or minus the square root. I'll write it this way this time, B squared minus 4 times A times C, all over 2 times A, okay? And then I'm gonna take the calculator, and I'm gonna go 7 squared minus 4 times 1 times -5, and I should get 69 for that, okay? 2 times 1 is 2. All right, so again, this is good, but let's see what that actually gives us. So on the calculator, I'm going -7 plus square root 69 equals, divided by 2, gives me 0.65. All right, and then -7 minus square root 69, and then divide that by 2, gives me -7.65. All right, and those are your answers for that. All right, so if you've been feeling good so far, that's good, because not too bad, right? These are gonna be a little trickier, and they're not gonna be worth as much, but this one says profit from business is given by this. They wanna know how many dollars should they do. In other words, we wanna know kind of where that vertex is. So what we're gonna do is we're gonna set this equal to 0. We're gonna see where our break-even spots are, and then the max profit will be halfway between them. So we're gonna use our quadratic formula. A is -2, B is 24, C is 25. So we're gonna go opposite of B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. Okay, so if I take the calculator and let's go 24 squared minus 4 times -2 times 25, I get 776 inside of there. And then this is gonna give me -4. All right, let me go ahead and work that out then. So -24 plus the square root of 776 divided by -4 is a -0.96. And then let's go -24 minus the square root of 776 divided by -4 gives us 12.96. All right, if I add these together and divide by 2, I want to find the halfway point between them. 12.96 minus 0.96, no, 12.96 plus -0.96 is 12. And if I cut that in half, the halfway point between these is 6. Now this was in terms of thousands, and so I want to chart, it says X is the number of items made in thousands, halfway is 6, so I want to make 6,000 items. That would be the halfway point between there. In other words, if you were looking at a graph of this, one of our x-intercepts is here at 12.96, the other one here is at -0.96, and our maximum is halfway right there, which is 6. That's where we want to be, okay? So that's how we do it. Again, there's a lot more work there, but that's kind of a nice advanced problem. Again, won't be worth much, but that's what we'll see. And then this one here, what are the key features of this? X-intercept is where y equals 0. So if I set this equal to 0, 18x minus 48. For this one, actually, I can divide everybody by 3 and go x squared plus 6x minus 16. And I can factor that into x plus 8, x minus 2, which gives me -8 and +2, or -8020, depending on how you like to write it. The y-intercept is when x equals 0. So if I were to put 0 in for x, that would go to 0, that would go to 0. I would get -48. All right, so those two I can do kind of quick. All right, if the x-intercepts are -8 and +2, I want to go halfway between them. Halfway between them is at -3. So I know the vertex has an x value of -3. As far as the y value goes, I'm going to put -3 into the equation. So I'm going to go ahead and go 3 times -3 times -3 squared plus 18 times -3 minus 48, and we're going to get a -75 for that. Okay. Now, as far as the domain goes, we can put anything we want in for x. There's no restriction there. So it's we're going to say all real numbers or any number or everything, however you want to say that. But our range is different because this graph goes like this. It opens up with a positive a value, and the vertex is down here at -3, -75. What that means is that there's no values below -75 that are part of this graph. So our range is y greater than or equal to -75. I can't have a y value any smaller than that. The graph doesn't go that far down. Okay. So that is our test tomorrow. You're going to do great.